pretty cool. Got the laser up and running on the second 3018, but should have made it a little bit darker, but whatever. Been thinking about this channel and had started working with the mini lathe in the mini mill some 5 years ago, and started the channel because there was nothing out there helping people with those machines specifically. And it's kind of a kick because I guess I turned out to be at the right place at the right time, because it seemed like everybody was getting into that hobby, and I helped a lot of people get started with it. So now it kind of seems like it's dying, but and pretty much so, anything you need to know or want to do, there's tons of videos, lots of Me Too's on different things out there. So I was thinking, I'm only going to start producing a Friday video now if I have something I think is worthwhile, something that's not out there, or something that's, you know, pieces of information are scattered to the wind, and so I'm going to bring it all together in one place. Also seems like the latest fad right now is the 3018 CNC and working with the laser, because I'm getting a lot of emails from people asking for help, so that's great. But okay, for this, I'm hoping I get this all right. There's a lot of information, a lot of details, so don't pound me too hard if I get something wrong. And why I got into this, I'll explain here coming up. But everybody saw I'm making my own arbors here for different chucks and so on, and I had made my own tool. It does have a nice little relief on it, angle, and it works great. And I know, yes, you're supposed to angle the compound, and so you're taking the load off the cutter. You're just cutting on this edge as you're going in. But it works just fine doing it this way too. You guys saw in the video making, I forgot which arbor, probably this one, under the stereoscope. The threads were just gorgeous. And also the dial indicator on these threads showing less than a thou worth of bounce, and that was probably more just the rough edges on the threads, because I never put Scotch-Brite or filed or did anything to them to clean them up. So this tool I haven't showed being used, but well, I guess you can see it in the new intro, but it's really nice. This was Amazon, $11. I'll put a link to it if you guys want in the description. So, okay, now, what do I know? Well, when I started with this, I thought I knew a lot, but turned out very, very, very little. You know, I knew 60 degrees, and I've got all the different gauges to check the scratch pass, and so this one is US only 60 degrees, and yeah, replaced the junky plastic knobs that it came with. So this is like a full set. There's everything in here all the way up to just giant. So I've got that one that I can use, and I've used it a lot to try to identify different threads and things that I'm trying to repair. This one is metric on one side, and then the Whiteworth is the other side, 55 degrees, and then 60 degree metric. So there's everything in the world in here, all the way down to incredibly, ridiculously fine. So I knew that stuff. What else? I just had some bolts here just for some visual aids, and this guy I picked up at a pawn shop for $1. It's a pipe thread, but interesting stuff. But all right, so let me put this to the side, and I'll show, yeah, just get rid of this for now. So I wanted to figure out what, well, no, I I wanted to figure out something else, but wound up going through the books. And of course, I'm going to go to my favorite book first, The Machinist Ready Reference. And there's no real descriptions in here on any of the pages of what the faces are and all this different things. And so, of course, I go now to the Engineer's Black Book, and same thing, nothing really describing anything. There's, you know, turns out there's tons of different types of threads, and it's like, why? I mean, everybody's got to come up with their own unique thread for some reason, but no descriptions in here. So that's kind of just first part I'm going to do was for education purposes. All right, let me bring some stuff over here. Did a nice little picture, move that out of the way, of some threads to just kind of show what's what. All right. So I think everybody knows basically from here to here is pitch. Probably should have had this thing all written out or drawn out, but okay, pitch. Pitch can be from here to here, here to here, middle, anything you want, especially because most of the time the threads are flat on the tip. So you got pitch, and then there's what's this face called? Flank. It's crazy. I don't know where they come up with some of these names. So you have flank. I probably should do this upside down. Okay. And then the peak too is called crest. C-R-E-S-T. So you got crest, and then the bottom here is called the root. So no big deal, and I know you guys, just like me, are not going to remember this tomorrow, but whatever, for what it's worth. And then you have the minor diameter, which is here. So this is minor. And then you have major diameter, which is the peak. Major, no big deal. M-I-N-O-R. Okay, so you have major, minor, and then you have the pitch diameter, which is the invisible piece in between here. Pitch diameter. Great, all right. So that's kind of the basic stuff that's in here. But what happened, what have I got? Anything else? Oh, and there's different types of these guys. You know, you're trying to identify it. Well, okay, it's 32 threads per inch, and it's a 1/2 inch bolt or whatever from here to here. But there's also multiple threads where you can have them paralleling one another. So that would be called a single start. This would be a single start. There's one thread just going around. A double start is there's 2 threads paralleling one another, and then there's a triple start. Those get more into lead screws from what I understand, but and then there's also and you're trying to thread something, there's lots of different ways of measuring it. You got gauge pins or whatever, and you mic them, and then there's a micrometer that can go in there, blah blah blah. But what was I going to say here? There's oh yeah, how deep you want to go. And I'll put a link to the place. Greene Tool Systems has some calculators on their website, which is really cool. But one calculator says how much do you want to have thread engagement between the screw and the nut. And for some reason their calculator only says 65, 70, or 75%. Why can't you go any higher? But I did some just playing around with it. You know, for instance, a 1032 screw. If you're looking at tables, it's supposed to use, because they have a tap and drill calculator. If you have a 1032, I know in other tables you're supposed to use a number 21 drill bit, which is, what did I write? 0.159. So I'm looking at their calculator, and all they want is tap diameter, which kind of blows me away. But I took 1032 4 flute tap, measured it, and it's 0.190 outside diameter. And then I said, all right, I want a 65% engagement on the threads, and it says you're supposed to use a 0.164 drill bit. Okay, so you got 159 to 164. I said 70%, and it goes just a tad smaller. It wants a 0.162 drill bit. And I'm starting to think, where are you going to find drill bits that are this kind of tolerance or size? And then for what the heck, 75% engagement, it wants a 0.160. So evidently the tables that I'm looking at saying you want a number 21 drill bit are giving better than a 75% engagement. But, okay, well, the reason why I got into this whole thing is because the second 3018 CNC is very old. It's an older model, and so the Z-axis lead screw was off. In other words, you had the motor here and the motor shaft and the coupling, and then the lead screw comes down here. But the thing is, the coupling, I'm drawing it wrong, the coupling was further down than the plastic piece here, so I couldn't bring this part up enough to hit the limit switch here. And it turned out the shaft was way too long, so I got the motor off, cut the shaft. Now the coupling is way up here. It clears this, so now I can go all the way up. But the problem is now the lead screw isn't long enough to stay in the hole. The hole is like way down here in this bottom piece. So I wanted to find another lead screw. And you go on Amazon, and I'm looking at them all, and okay, it says it's for the Z-axis CNC. Let me show you a picture. This is the picture of what I got. Everything says it's 8mm, it's a 2mm pitch, it's a one start, so it's a single thread going around. But look at the angle of it. It's like, whoa. So, now it gets into researching why I wound up into all this. There is something called a helix angle here. Now let me stop this camera for a minute. Gotta break this up into a couple of sections here. The pieces get to be too big to edit. So there's something called an helix angle based upon a vertical axis here. That would be the angle. And that's, you think about it, on the mini lathe, wow. What did I write down here? I gotta go to my cheat sheet. That's what I said. This is like really complicated to cover. Yeah, all right. The website, the Greene Tool Company Systems, has a calculator for this angle. And I started just for the heck of it. Evidently, it's for imperial only. Because you plug in metrics and you get like 85-degree angle. Like, no. But evidently, it wants diameter and threads per inch. Seems like every single screw I plug in has a different helix angle to it. And you look at them, and they look the same to me, but they're really just slight, 1.5 degree, 2 degree. You can't see it. And I'm thinking, wow, on the mini lathe, even a full-size lathe, some genius had to sit there and figure out the lead screw and the change gears to be able to do all these different helix angles for the correct bolt. And because you can't control the angle on a lathe. You just say how many threads per inch you want, and you go. That's it. And it doesn't matter on the size of the bolt, too. I mean, I could be 18 threads per inch on a 1/2 inch or a 1/4 bolt. Actually, what do they have? Oh, I don't have anything here to show that. But then I'm thinking, because little machine shop has tables and things showing, well, the lathe itself has the table on the side for imperial threads, which gears you use. But the LMS site shows what gears you can use to cut metric threads, but it also shows error, what kind of error, percent error you're going to have in the threads. And then I started thinking, gee, on the lathe, I wonder if the threads I'm doing, you know, where'd they go? These threads or whatever, do they have error in them? I don't know. And here I'm counting on them being perfect, trying to make these arbors, and it's working out. But there has to be, I'm guessing, some kind of error in these threads too. So, okay, that's what's controlling it. Now, you can't control helix angle when you're doing imperial threads, but boy, you sure can control it here when you're doing a lead screw, an acme thread. And then that was interesting, thinking about that and watching some other YouTube videos, because everybody's got the tool in there and they're just cutting them. What are you doing for the helix angle? Because now whatever change gears you have is setting your angle. I haven't seen anybody talk about that or even discuss it, talk about it. Okay, but there's a heads up on that. If you're going to do acme threads, you got to figure something out here on what you're going to do for change gears. Additionally, acme threads, you're supposed to take the tool. You can't go straight in. You're supposed to angle it to do that thread. And I see people just cutting it straight. So there's another one. Also, kind of a kick too is, I know you're supposed to, I don't know if I mentioned this already, you're supposed to do an angle. Yeah, I did. Supposed to do an angle, but it's a kick. I see everybody doing the same thing. They'll go in, they'll make the cut, they'll come out, they will not disengage. They'll run the lathe backwards and then go back in and do the next pass. I'm doing that strictly because the engaging claw, wherever it grabs, doesn't give you a perfect thread. It's slop in it, and I think that's happening in the larger lathes too, because I'm seeing, like I said, people coming out and they put it in reverse. They will not disengage. So acme threads I'm still searching for. I kind of gave up, but yeah, helix angle, it's been in all the pictures, never tuned into it. So I think this is everything I want to cover. I mean, the Greene tool companies, cool calculators. One thing I forgot to mention is this right here is called the thread angle. Very complicated term to remember. But I did some playing around off screen, off camera. Because I did say I didn't know whether the lathe had introduced a problem or whatever with respect to the helix angle. 3 screws. They're all 32 threads per inch. I did use the calculator on that website, the Greene Tool Systems, entered in all of these guys, and you can see here they are all a different helix angle, 4 degrees, 3, basically. So you, between here and here, you've got a whole degree off. So right there, the lathe is not going to account for the helix angle. When does that come into play? And I did experience it, I believe. So when you just have a nut, you can't see here, but there's a lot of play in this. And you have what, 3 or 4 threads engaged. So it doesn't really make that much of a difference. When it does impact you is when you're trying to put something long on there. If these angles don't match, then it's going to go on so far, and then it's going to jam and won't go on any further. And I believe I had that. I had a rethreading die that I had threaded what was going to be a screw, and a nut went on it just fine all the way. But when I tried the thread protector, it only went on so far and jammed. So be aware if you're turning a screw or something on the lathe, it's not accounting for the helix angle, and you could wind up in a problem if you're making a screw that's going to go into a deep hole, deep threaded hole. Side note here, was just doing some playing around with the CNC, saying, let me make something a little bit more complicated, and it's pretty easy to work with. This was going to be a flywheel. I forgot to do the center hole, but yeah, it can easily do the center and then these holes, but I spent hours and hours trying to get it to do the outside of a cylinder, and it would not do it. Turns out it's a bug in the software. I'm running version 0.17. They came out with version 0.18. 0.18 works. It'll do it perfectly. So I kind of gave up on this for now because I did accomplish what I wanted. I wanted to try to do something a little bit more complicated. So if you're running FreeCAD, go get the latest and greatest. So the bottom line is, if you're going to play with lead screws, there's a lot of variables involved, particularly the helix angle, angle of the threads. This is the third one from Amazon. That hasn't been returned yet. The other two are gone. Clearly states 8mm, perfect. It clearly states 2mm pitch, perfect. Does not tell you what the helix angle is. It does say it's for a CNCZ axis. It's very, very close. It's the best one I've gotten yet, but it does not work. So the existent nut won't go on it. And I could use this nut, but the bottom nut in the Z-axis assembly, it won't thread into that. So I'd have to buy another one of these from the same source, so I know I got the same thing, and then try to push the bottom nut out and machine this to fit it. So not going to happen. Okay, so that's all I wanted to say in this video, primarily a new thing. I did remachine, you can see this guy, the ER11 holder, because the sizes I had handwritten in, and it was kind of cheesy, but so pulled the old program up, said redo all the holes, and then pulled that, exported that as a DXF, pulled it into Lightburn, put all the text underneath each hole, deleted the hole pattern thing, the DXF, and said burn it. So came out really nice. I'm very thrilled with it and where I can go from here. So I hope I see you guys next Friday.